It is on centralized.
Okay. Oh god, so anyway, basic point is we want flow rates, and we're going to have a chart of our flow rates, and based on that we are going to, I really don't know what we're doing in this class, I have no idea what the point is. Sorry. It's flow rates versus valve opening percent, plotted for valve open percents from 0 to 100 at 10% increments on that chart right there. Those are your flow rates. Originally we were going to cross-reference this with how far the air valve was open, but we discovered that since the mass flow reader for the water is at the top of the column, it's not going to be affected by airflow. So we kind of just left it with the valve closed for air. It seemed like it wasn't going to make any difference. Now if you were reading at the bottom of the column and actually collecting the water down there, it would have some effect, but for this it doesn't. And here's some pictures of the apparatus. This is actually close to the bottom of the column. From this angle you can't really see the U-bend in the glass because it kind of goes back and away. But it shows just like where the water inlet is and the base of the absorber column. You see the column itself. I have a pointer. You see the column itself up there, or alternately over here, depending on which way you're looking. The U-tube's at the bottom. There's the inlet for the water, which goes all the way up and then back down in some convoluted fashion. That's the top of the column. The water actually enters the column approximately right here. You can't see it really well. There's it. You can't see the pipe. It's right there.
Yeah, right there.
There it is. Air will come in from the bottom, and basically how much air is being absorbed into the water. Which there's a measurement apparatus for that. Next slide. And that is the end of our presentation.
Wait a minute, what's all this energy going into clapping? One is enough. One gets the point across. Let's try it again.
That's it. Don't do it again.
Really?
Yeah.
It's a waste of energy.
See?
Isn't one clap a waste of energy? Can't we just wait?
Mark it up.
Yeah, but there's a point, I
Is
think.
there a point? You gotta show appreciation.
A point that we know that you're finished.
Yeah. Oh man.
What, somebody jump in front of me?
Yeah.
Yep.
Oh, does the thing on the top not work anymore?
You didn't see it, but you gave it.
There's a USB thing there on a cable. I don't know if it works. Try it and see. It works. Saves your knees. Both of y'all going to give part of the presentation?
I'm going to be clicking it first.
You're the clicking person?
At first.
At first.
And I'm going to take over the clicking and let him talk a little bit too. Okay, my name's Dustin and this is David, who is in the water absorption group. And our objectives right now, just to become more familiar with the unit's operations laboratory, kind of learning about the apparatus we have to use, and also have to conduct experiments at the absorption column to calculate the SSOC of water flow of the absorption column. Procedure we have right now, I'm going to manually check to see that water and airflow are flowing at correct constant rates using the manual VI. Run experiments using the constant function where water will be taken with 5 different constants for 3 seconds each, and air will remain at 1 constant throughout the entire experiment. And also take data from the 5 different runs, export them into Excel, then construct a graph of the SSOC for water at the absorption column.
As you can see here, we made a flow diagram. This is a really basic flow diagram of the absorption column downstairs in the unit ops lab. Really basically the water comes in through the hose, flows down into best that I know of, the water meter, and then it flows up a aluminum tube into the top of the absorption column, and then flows down that through the plastic tubes, and then goes into the U-shaped tube, and it flows out into the drain afterwards. And then we have some pictures. As you can see, the green hose right here is the water line that flows down, and then click on the next one. Keeps flowing down, and there is the fluid meter. I'm not honestly sure what that's called, so I hope to find out. And then it goes up the aluminum tube, and then into the top of the absorption column, and then back down again into the U, and then out to the waste drain. And go and click the next one. And we are still assembling our data. I've been to the lab several times. I guess I'm just lucky of hitting it when it doesn't work. But I just ran some results, some experiments last night, and they popped up working this afternoon. So, well, because it was funny because I ran them last night at, I ran one yesterday afternoon, and I ran one last night, and then I got on, and they both have ran today at 1:38 this afternoon.
Yeah.
So I had no idea that it would take 12 hours for things to run, or how many hours that was. Well, is it? Is it supposed to take that long? 12 hours?
It was supposed to take about 6 minutes.
Yeah, I know, right?
6 minutes, an hour if there's a wait.
Well, see, it has on there the time that I tried to do it, and then it said completed, I tried to do one 9:30 at night, September 10th, and then it completed today, September 11th at 1:38. I have no idea why.
Now, were you able to actually just put the flow test in your exact way that you described, and it did 5 different steps for 30 seconds at a time?
No, each experiment is at one constant.
For each one? Like, is it?
What do you mean for each one?
As in, it was like water valve was 20%, air was 0?
Yes.
Oh, that sucks.
So now that I know that do you know why that happened?
Yeah.
Dr. Henry, why that happened?
Oh, you want me to answer a question? Dr. Ennis told me I was supposed to answer questions.
Oh, you weren't?
Yeah.
Can you do me a favor and answer your question?
Yesterday, there was another team in there doing something, and when they were through, they decided to shut down LabVIEW.
Oh.
And I noticed that this morning, and I thought, well, I think I'll go in a little bit early, maybe about 1:30, and turn it back on. So there's a queue of all the experiments that have been requested,
Okay.
and it ran them in order at 1:30 or whatever this afternoon.
You stopped at 8 minutes?
That's why. All right. So that shouldn't be a problem anymore,
Pardon?
unless someone turns off LabVIEW again.
It shouldn't happen again unless somebody turns off LabVIEW or something else happens.
Awesome. All right.
There are about 1,000 things that can happen.
Oh, I'm sure. Yeah, I'm sure there are. But all right. Well, I just wanted to know why, because you're the mastermind behind that whole thing. So
Yeah. I'm trying to figure out University of,
University of Alaska at Southeast.
but you got an orange hat with a white T on it.
That's right. University of Tennessee.
Serious?
No joke. No food.
They have one of those in Alaska too.
University of Tennessee in Alaska.
Yeah.
They do.
University of Alaska where?
It's great.
Southeast. It's in Juneau. Juneau, Alaska.
You been there?
I have. I was there for 14 weeks during the summer, about 2 summers ago.
Good.
Yep. Good.